We're going to take a few minutes to talk about a quick but important topic called average rate of change. And I just want to start with this example, which will hopefully put a logical spin on it. I have $1,000 in my bank account today. If a year from now I have $13,000, what was my average rate of change in dollars per month? And the point here is that I gained $12,000. Okay, my balance a year from now, which let's call that f of 2, minus my balance right now, f of 1, is 12,000. I gained $12,000, and the change in my x value is 12 months from now minus right now, which is 0 months from now. So long story short, I gained $12,000 in 12 months, so I gained $1,000 per month. Now, the follow-up question is, what's the least and most amount of money I could have had over that year? A lot of things could have happened in this year. I could have gone broke. Let's assume that 0 is the least I could have in my account. But right now, I've got 1,000. And down the road, I have 13,000. No matter what has happened throughout this year, I have still gained, on average, $1,000 per month. That's what an average does. Okay, I could have gone broke, been broke for a little while. I could have won the lottery, could have blown all of my lottery winnings. I could have had a normal job and done some normal things. And I shouldn't have backtracked there, but you get the idea. No matter what happens in the middle, I still went from 1,000 to 13,000. And the point of that is, I don't care what happened in the middle. I don't care what the function is that describes how much money was in my bank account. The only thing that matters is what I had at the beginning and what I had at the end, and how far apart the beginning and the end were. So if I had to sum this up, average rate of change is just the slope. Has nothing to do with the function, has nothing to do with the derivative. It's just the slope from point A to point B. Okay, here's another just kind of typical example that you would answer in your everyday life. If it took me 16 hours to drive 578 miles to the beach, what was my average velocity? Well, at some point during that trip, I was probably driving 75, 80 miles an hour. At some point, I was stopped to eat lunch. I was driving 0. I was sitting in traffic going 10 miles an hour. All of those things are irrelevant. What matters is that I went 578 miles in 16 hours. I'm going to need to type that in my calculator. 578 divided by 16. I went an average of 36.125 miles per hour. Okay, average rate of change. And that a lot of times, just like all of our derivative examples do, applies to position, velocity, acceleration. Next, this topic of average rate of change pops up a lot on the AP exam, and it's not quite, I wouldn't call it a trick question, but it's a question that a lot of people overthink, and they try to take the derivative because you've been taught that a derivative is a rate of change, which is true, but the key is its average rate of change. Now, this is a question from a couple years ago. The grass clippings in a bin, they start to decompose according to this function. It's the average rate of change over the interval 0 to 30, indicate units of measure. So I encourage you to pause and answer part A, and then see if you can follow up with part B before you see my answer. Okay, so I'm back with the answer to part A. The only thing that matters for part A is what was the value at 0 and what was the value at 30. I'm just finding the slope. I plug in the two x values to get 2 points, and technically this is an Algebra 1 question. It's the slope between the points 0, 6.687, and 30.783. And we lose on average 0.197, and this is in pounds per day. Okay, that's an average rate of change. The derivative was never in question, and the only reason the function mattered is because I had to plug 0 and 30 into it. What was happening in between 0 and 30 has no effect on my answer. Now, a lot of times the follow-up to that will be a prime of 15. Now this is why we need a derivative. A derivative is an instantaneous rate of change. So again, see if you can find that. This is going to be a calculator problem. What we want to do is enter in the function into our calculator and use it to calculate a prime of 15. I'm going to pause and calculate that and be right back with the answer. And my calculator gives me, in that case, negative 0.164 pounds per day. And we would expect something close to the average rate of change. Not necessarily the case, but this is an exponential function, so it's kind of a gradual changing slope. And this is a reasonable answer. Okay, so we've got average rate of change versus instantaneous rate of change. Average is just the slope. Instantaneous, use the derivative. And here's one more. I want to find part D, which is the average rate of change of this function. This is a non-calculator function, non-calculator problem from an old AP test. Average rate of change of the function on negative 4 to 3. And they've got some explanation about the mean value theorem, which we're not concerned about with this particular video. All I want to know is that, and I'm going to answer up here where I've got some space, I went from this level right here, which was a height of negative 1, down to this level right here, which was negative 3, and we can tell that that is a drop of 2. Negative 3 minus negative 1 is negative 2. But just to kind of put it into formula, I'll just kind of lay it out in the slope formula. And that happened over an x increase from negative 4 to positive 3. So that's 3 minus negative 4, which is 7. So I dropped 2 over the course of 7 steps, and as you can see, this is just simply a slope. This is the average rate of change of this function. And you can see what this function did. It went up according to these little quarter circles and went down according to this straight line, but it makes absolutely no difference what happens in between here. I could have also followed this path to get from blue dot to blue dot, and I would have still gotten negative 2 over 7, because average rate of change is just a slope, and that is what you need to take from this video.